Hello, my name is Debra Caruthers, and I'm recording this video to show the program I wrote for establishing a secure server. And first I will show you the code, but first I want to show you how I used OpenSSL to generate the public key and the private key file. These are file extensions that end with CRT and then KEY. And here is the code for the server.crt file, which we will use in the program. I thought this was very cool because this has a lot to do with my other class, Cyber 404, where we've been talking about the modulus. And here we have the signature algorithm is shown here. And then in the other key, which I'll scroll down my Windows terminal program, down to server.key is this file. Again, we see the modulus code, and here's the public exponents, the private exponent, the prime number, functions that was used to create this key. So I thought that was quite cool. And now I'll show you the program. Oops, let me scroll to the top here. Yeah. And let's talk about these import files. Here we have, let me get my little script up. First, we import our libraries, the OS, ArcParse, and system help with system level tasks. But then we also import socket and SSL are the star libraries of this show. The socket lets us create network connections, and SSL secures them with transport layer security, TLS. And then let's go down here to where those public and private key files are shown down here. Oops. Right. Okay. Here's my command line to create a TCP IP server socket. And here we go. So here's that key I was just showing you from my Windows PowerShell terminal command line. And then here's that second key. So those two keys have to be in the same directory as where I store this Python program, which they are. So after establishing those variables, here's my main function. Here's where we create the TCP IP server socket. Here's where we allow the port to be reused immediately after the server stops. Here's where we bind the socket to an address and a port. Then the other activities here, listen for incoming connections. Let me scroll up a little bit. Create an SSL content for secure connections. And then here, okay, here's where we load that certificate and key for TLS encryption. Get my, right. And then this main function is the heart of the server. It is an infinite while loop inside of a try block. It's wrapped in a try, so I can shut it down cleanly with a Control-C command. Inside the connection socket, address, server socket, except those lines wait for the client, which we're going to use the curl command in my Windows terminal to connect to it. And when it does, I get a new socket, connection socket, just for that curl client and their address, which I print out, which we'll show later. For each connection, I secure it with secure socket. This down here. Right down here. And then we have these other print statements. Inside a nested try, I receive the client's request with a secure socket RECV. This grabs up to 1024 bytes, enough for a basic HTTP request, like a GET request. And after sending, I log the request and response with some print statements. That's down here. And then I also included a secure, I call it a graceful exit to shut down the socket. This does a proper TLS shutdown, sending a close notify to the client so that it's not abrupt. The secure socket close frees the socket. Yeah, so right here. This combo fixed an error I had with the curl command complaining about connection reset. So this made it a graceful, clean close. Now let's go down the parse request function here. Parse request function down here. This takes the raw HTTP request string and splits it into lines. The first line, like a get line, gets split into method, path, and version. Then I parse the headers into a dictionary. If anything's malformed, I return none values to signal an error. Now, okay, here's the HTTP handle function. This is where I build that response. I call parse request to break down the input. If it's bad, I return a 400 bad request message. I only support the HTTP 1-1. Anything else gets a 505 error, and then only get is allowed. Otherwise, it gets a 501 error. Now, down here, the response building is kind of interesting. Okay. Right. Okay, so down here is where we build the response we want to get. For a get, I create the HTML body first. It's just a simple web page saying hello. It's my own custom hello message that mentions how the keys came from OpenSSL. So I'm not calling an actual file. It's just building the page, virtually right there. And then after that, we're pretty much done. You have a request to handle a fave icon request, and then that's it. So now let me show you how this actually works in my command terminal. So first we'll show the socket message. Okay. All right. Oops. Kind of slow. All right. Do this. Like to make sure I'm in the current version of PowerShell. And now we're going to call the program. And here we get our message, secure server ready on localhost 2080. Okay, now we're going to go back here. Okay. Now I'm going to call my client with a curl statement. I'll even show you the verbose response just so you can see. Right, so we got our, here's the server messages. And we'll run this again so you can see it in Wireshark. But here I do get my custom hello message right here. And now I'll turn on Wireshark so you can see this again. There we go. Okay. And let me issue that curl statement again. Let me do it again without the verbose part. Okay. Okay. So we've generated some traffic in our Wireshark. Yes. And of course I have it, oops, I wanted to filter that. So in my Wireshark, we're going to see lines that identify the TCP handshake and then the TLS handshake, and which is where the SSL secures it with my OpenSSL certificate key. And then we have some application data. So let me filter TCP. How did I do that? Let's just filter. Okay. Right. And we can see that down here. Okay, so like for that last request I did, here's my TCP lines. Let me make this a little bigger. Okay. All right, and here's getting the key. And then here is the client hello on TLS V version 1.3. So there it is. And of course, we can't see it because it's encrypted, which is what we wanted it to be encrypted. So that's why it looks different from the previous assignment. And here's the other lines. The server hello. Here's the server hello. The server response. It's all encrypted. And this line was interesting. Change cipher. Oops, didn't mean to go all the way big like that. And application data. And that's it. Okay. So that is the run through of my Python program to establish a secure server. And we showed issuing the commands in my Windows PowerShell. And also, let's see, I wanted to show, I don't have that shared right here. Can you share that? Well, anyway, so let me see if I can do this. Let me get my Zoom window again. Oops. There it is. Let's do share. There it is. And if I browse my localhost 2080 in a web browser, this is what I get, my hello message. Okay, that concludes my video. Thanks for watching.